130 million years ago, while dinosaurs still walked the Earth, a pair of dead stars collided. The explosion rattled space-time and sent waves of light across the universe. On August 17, 2017, light from that explosion appeared as a bright pinprick in the galaxy NGC 4993, and then faded to a glowing red ember. Ripples of traumatized space-time from the distant explosion squeezed and stretched the L-shaped arms of the LIGO and Virgo gravitational wave detectors. Converted to sound waves, the ripples produced a faint rising chirp. 2 seconds later, NASA's Fermi Space Telescope detected a gamma-ray burst, a brief glint of high-energy radiation from one of the most violent events in nature. Astronomers scrambled to point their telescopes before the precious light faded away. First on the scene was the SWOPE telescope in Chile. Right on its heels was the nearby Dark Energy camera. The antennas of the Very Large Array strained to record radio emissions from the fireball. Even the Hubble Space Telescope turned its peerless mirror toward NGC 4993. Within hours, the distant explosion had become one of the most observed events in recent astronomical history. Astronomers think the story began with a pair of massive stars that were orbiting each other. The larger star ran out of fuel and collapsed into a dense neutron star. Neutron stars are the densest visible objects in the universe, spinning dervishes bristling with powerful magnetic fields. A teaspoonful of this star stuff would weigh as much as Mount Everest. The intense gravity of the neutron star began to steal gas from its aging sister star. The swirl of hot gas dragged the two stars together until the neutron star began orbiting inside its sister, shredding its outer layers into a swirling cloud. But the sister star survived this mutilation and eventually exploded too, collapsing into a second neutron star. The fuse was now lit. Twin spheres of incredible density were now locked in an ever-tightening dance of doom. Shedding energy in the form of gravitational waves, the two neutron stars spiraled closer and closer, faster and faster, and finally merged in a moment of astrophysical ecstasy. A kilonova explosion, a crucible for cosmic alchemy. The swirling cloud of superheated atoms was bombarded with neutrons, forging new atoms of gold and platinum and other heavy elements. Scientists think that most of the precious metals in the universe were created in kilonova explosions like these. When black holes collide, there's nothing to see, though LIGO can hear the chirp from their gravitational waves. But neutron stars are visible matter and collide within a glowing cloud. This was the first gravitational wave catastrophe that astronomers saw as well as heard. Our first glimpse of the mysterious physics inside neutron stars, and a first fleeting glimpse of a cosmic mint in the sky.